Hi, welcome to episode 65 of the eBPF and Cilium office hours, also known as eCHO. If you're watching, do say hello in the chat, whether you're on YouTube or I think we're now streaming to LinkedIn and Twitter. And so wherever you're watching, if you're able to comment, we should see those comments coming through, and we always love to hear from you. So I already see regular viewer Russell saying hello. Great to see you, Russell. And Quentin, who I believe is moderating for us today. And it's always great to have you on board, Quentin. Right. So this week, let's bring up the headlines. As always, the show notes are on HackMD. You can find the link. That side. HackMD at echo-live, and you'll find show notes for every episode there. If there's something missing and you want to add it in as we go along, then please feel free to do so. So before we get to the main topic of today's episode, which is going to be a new project called Bpfd, but before we get to that, let's talk about some of the headlines. For some of us, the impending big event is KubeCon. That's coming up in just a couple of weeks' time in Detroit. I hope that we'll get to see some of you there in person. If you are there, please come and say hello. In particular, a couple of things we want to point out from KubeCon. Cloud Native eBPF Day, which is a co-located event happening on the Monday. And I think I've got the agenda. Have I? Yes. So this is actually something that I'm going to be hosting along with Sarah Novotny from Microsoft. And we've got a ton of really great content throughout the day at Cloud Native eBPF Day. So it's a separate registration required alongside your KubeCon pass. But I hope that we'll get to see some of you there. We also have another event that I really hope some of you will come and say hello at, is our first ever in-person Cilium project meeting at KubeCon. So we've been allocated some time on the Tuesday morning to have some discussions, whatever we want to talk about. We've put together a document where you can sign up and let us know what it is you'd like to discuss, whether you've got ideas for new features, or you want some help with a PR, maybe you want some help with a presentation or some docs, or anything you want to talk about related to Cilium. We'd love to see you there. So that's on the Tuesday. Link in the show notes to the sign up form. Hopefully you all already know that eBPF Summit happened a couple of weeks ago and all the videos are now live. I've been catching up with some of the videos that I didn't have time to look at on the day, and there is some really great content there. So I thoroughly recommend checking that out. All right, moving on to some of the news and headlines and posts that we found around the internet in the last couple of weeks. This is an article by the analyst firm Redmonk, and they're talking about why you should pay attention to eBPF. The fact that you're watching this tells me you are paying attention to eBPF, but it's really great to see the broader industry telling us about what it is that's attracting their attention. Why should you pay attention to eBPF? Hello to Viday, who is watching from sleepy in Seattle. I guess it's pretty early for you there. All right, the next post that we have is a blog post on the Cilium website. And it's written up by Bill because the particular user we're talking about is anonymous, but they're basically a very big name in publishing. And they have a great story here about how they're using Cilium in a very widely scaled multi-tenant environment. So check that out on the Cilium blog. We also have a post here from ContainerIQ, who are talking about how they're using eBPF to decrypt SSL at scale, which sounds pretty interesting. And I think this could be really both interesting and possibly a little bit eye-opening that how you can use eBPF to decrypt, well, show traffic either pre-encryption or post-decryption from the kernel. So that should be really interesting to check out. Another article, I thought I was going to, okay, well, I'll cover this one now. Eunomia BPF. This looks pretty interesting, and I think this could be a really good topic for a future eCHO episode, actually. Kind of in the same overall sphere, I think, of what we're going to be talking about today with Bpfd. This is another framework around loading and managing BPF programs. So it'll be interesting to compare with what we're about to see today. Very interesting that Eunomia talks about compiling and distributing code in JSON or WASM form. So I'm going to check that out. And yes, this is the last of my blog posts from this week. From Ground Cover, the Goodbye Sidecast title reminds me of a post that we also wrote at Isovalent. But this is a really, really nice to see other folks in the eBPF world talking about how eBPF can benefit and make service mesh more efficient and less resource intensive. So it's really great to have some more opinions in that discussion, which I think is going to be a hot topic at KubeCon. So if you are in Detroit or if you're online and watching the conversations, that could be a really interesting conversation to get involved with. All right, Daniel, hello to Daniel. Who I used to work with at Aqua. So great to see you, Daniel. He's asking where we find the links to the article. So it's a good prompt to remind again. The show notes are all on the HackMD that you should find if you follow the link that's there in the bottom right-hand corner. That will take you to our set of weekly show notes. And also let's say hello to Bora. Nice to see you. All right, so I think that's pretty much all of the headlines that I want to cover today. And I think without further ado, let's bring in my guest. Hi to Dave Tucker. Welcome.
Thanks, Liz.
So Dave is a repeat guest back in episode 25, which must be at least 6 months ago by my calculations. Dave was here talking about Rust and IRE for eBPF. So good to have you back on the show. Good to have a repeat guest. So today we're here to talk about something that I believe is built using Rust and IRE, and it's called BPF Daemon or Bpfd. Which name do you prefer?
Well, we've been calling it Bpfd. The name may change. I think Google searches will prove that there have been multiple attempts to do something with this name in the past, but all of them appeared stale. So I just thought, well, why not? It describes what it is, so we'll just reuse it for now.
Yeah, it was actually kind of interesting when I was doing a little bit of research before this episode and finding things like Jess Frizzell's Genuine Tools. She has something called BPF Daemon. So you're clearly following in some illustrious footsteps with that name.
Exactly. I hope Jess can forgive me for reusing
it. And my kind of initial reaction when I hear that name is it a bit like Systemd, but for BPF? Is that a good place to start?
Yeah. So, I mean, I came to this from, so I've been working with BPF for like a couple of years now, and specifically on the user space bits. So like the loading library stuff in Rust, which I help maintain. But just really trying to understand, like, what does it mean when we start relying on more BPF? So obviously you have projects like Cilium, which want to use XDP and TC hooks and various other things. And then you've got tracing software that wants to use BPF. And then you've got load balancers that want to use BPF. And then you've got like actual debugging tools that want to use BPF. So when everybody starts using it and we start using it more, then what does that mean for me as a system administrator? Like, how do I get an idea of what's happening? Like, BPF tool is good because it tells me what the kernel sees, but it misses a whole bunch of intent of like, why is that specific thing there? Like, who is using that? Not just what is the program called, but like, which freaking process put that on my system, and why is it running here? So I wanted to build something that might help try and demystify some of this. And I guess the other bugbear as well. So having worked for a long time in the container space, and having to hit that motto with everybody all the time, containers do not contain, to then see people trying to run BPF, and the answer is, oh yeah, that's fine. You just run it in a privileged container. It's loading, some stuff into the host kernel. Like that didn't fill me with joy. So I was also thinking that there's definitely a permissions element to this, of rather than just being the Wild West of everybody on the system can suddenly go and adjust the host kernel without knowledge, that we wanted to try and restrict that much more than the Linux capabilities model allows us to do.
Oh, that's really interesting. I'm just going to quickly say hi to Moz, who's joined us, and also to Jed. You have such an unusual username there, Jed, but I think I know which Jed you are. So hi, great to see you. So you talked about like the confusion that can exist if you look at, let's say, a list of BPF programs from BPF tool. And you also talked about the kind of problems of multiple programs potentially hooking into the same interfaces. I'm kind of curious, like, which of those problems, I mean, obviously you're trying to solve multiple problems at once here, but which of those was the thing that made you go, oh, I'm going to build something here?
Well, the short-term thing was really about XDP. So in playing around with all of the BPF, trace points are great, K-probes are great. I can just throw as many of those at a system as I want, and I don't need to think. But XDP is very much one of these programs where it's like, nah, first one, exclusive rights, that's it. It's the only thing that gets to run on an interface. And this is a semi-solved problem. It's semi-solved because libxdp exists. So Toki and Jesper, who co-develop XDP in the kernel, came up with a way of doing this in user space so that we can have cooperation, but it was kind of too complicated to fit into libbpf, so not everybody can use it. So libxdp exists, but it doesn't solve the use case for me selfishly. I'm a Rust developer. I don't have an implementation of this protocol, but it also doesn't solve the problem for people that use the Cilium BPF Go library as well. So I was at an impasse. I was like, well, either I'm going to go and contribute this multi-prog protocol to the Cilium library and do that in Go, and then I'm going to write the same implementation again in Rust, and then we're going to test them all and they're going to work. Or like, maybe I could just write the code once and then maybe, have a better, a more well-defined interface using gRPC, because then I can just generate the bindings for any language. So if somebody wants to load BPF code from Java, like, sure, why not? You want to do that? I can generate bindings for you. The problem is solved. Like, we don't need to re-implement the same protocol in a whole bunch of different libraries.
If anybody out there is writing eBPF code with Java user space management, I would love to hear about it.
Yeah, hands up.
So you talk about, the administrators being able to sort of control what's happening in terms of which BPF programs are being loaded, and maybe what priorities those have, because presumably you're going to have to choose who is, or whose application is going to be allowed to hook onto this interface. So how do you kind of specify that? How do you define that?
That's a great question, Liz. So I have managed to get a little demo working quickly. So I will just go and attempt to screen share and see if I can get this working.
All right.
All right. Does this work? Can you all see a screen?
I think it might need to be a little bit bigger, but it's there. Yeah.
We can go bigger. Let's do it.
Wonderful.
All right. So I have Bpfd running in the background, and what I'm going to do is I am going to go and load an XDP program, just a really simple one that just says, like, allow all the traffic through. But you can imagine it being way more complicated if you wanted to. So let me find a load. All right, so I'm going to load a program onto ETH0, which is the interface which is running on this virtual machine. And I'm going to pick a priority. Now, what this multi-prog protocol allows you to do is it will allow you, when you package your application, or when you actually write your BPF application, you can specify some metadata about it, saying, well, I reckon that it should probably run at around about this priority. But what Bpfd allows the system administrator to do, I'm loading this here with the command line, but plausibly, this could be rules in the daemon config that say, well, me, the system administrator, knows best. So actually, I would like this program to have, priority 50 or priority 10, like regardless of what the application tells me it wants. I'm intelligent enough to make that decision for myself of where it will sit. Now, the other cool thing about this is that it's got this -- from image flag, and the bytecode itself is actually stored on Quay.io. So rather than having to have that bytecode locally available, Bpfd can actually go fetch that from any OCI registry and then unpack it and then do the load locally on the host. So we've kind of also by extension solved one of the distribution problems, which is fun, because then you can potentially defer loading to Bpfd and not have to worry about writing user space loaders and scheduling daemon sets in Kubernetes and all of the other fun stuff that you might need to do to get this to run inside a cluster. So if I can list out then the programs that I've got attached, so I can do a BPF Guttle list.
I was wondering if we're going to have the debate about how you pronounce that.
It's BPF Cuttle. Fight me.
That's what you say. Okay. You may have written it. I'm going to say BPF control, but that's.
Oh no! All right. We'll agree to disagree on pronunciation.
Absolutely.
But I'll show you now that at least I can say that at the moment I've got a single XDP program is attached to this interface ETH0. I've got this UUID, which is my unique reference to this attachment. Now, this is a user space Bpfd concept. The kernel doesn't know anything about this. If I were just to show you a BPF tool prog list, what BPF tool is going to see is going to be a bit different. So BPF tool is going to see that I've got this program here, which is a dispatcher program in XDP, and it's going to see that it's got this cool extension type program here on 717. Now, this is my actual code. So the way that this multi-prog protocol works is that it loads a dispatching program to the interface, which gets that exclusive control. That dispatcher has like 10 functions within it, which are stubs. And ultimately what we're doing here is we're replacing one of those stub functions using the BPFF replace type program with some actual executable code. So when we come and put another one in, we'll have 2 stub programs attached, and then 3, and then 4, so on and so forth. So that's cool. That's one program. Now, the thing that Bpfd will also let you do is I'm going to go and put in another one. But this time, this one's super important. So I'm going to make this one priority 1. And then, why not throw in another one at priority, let's have a think. Let's go for 142. And let's go list out those. So what's happened here is that my priority 1 program has got inserted ahead of the other programs. And that happened with some magic in the background. We've replaced the dispatcher using atomic replacement. So none of these other programs that were attached would have noticed any interruption at all in terms of flow of packets. They would have still seen absolutely everything that we're expecting to see. But everything has kind of been dynamically reordered on the fly. So if I wanted to, I could do something like unloading a program. So I could also do an unload of, where are we? ETH0, that one in, and then list out again. And now my middle program has disappeared, but these other 2 are still processing packets. So from an XDP standpoint, it gives me that flexibility now of being able to say, all right, I want to run my firewall right up at the front, because that's going to be dropping some things. Maybe I'll put that on priority 10. Then I've got a load balancer that also uses XDP, which I'm going to run afterwards on priority 100. But also I want to use XDP dump because I want to like get some information about the traffic that's was permitted by the firewall before it got to the load balancer, or maybe I want to run the dump after the load balancer, or maybe I wanted to run the dump before the firewall. I can play around now as an admin and kind of put my tracing tools wherever in the chain that I want to, so I can get the information I need to go and solve a problem, which I think is a lot of fun.
That's really cool. So presumably the eBPF program itself, or the XDP program itself, is unchanged. You don't have to modify that in any way.
Nope,
And
it's just at load
through this
time, we just tell the kernel it's not an XDP program. It's actually an extension type program, which is compatible with these stub functions. So we have to get ourselves in the load path to intercept that to make this work, which is kind of why it made sense in some ways to have a daemon, because it's always running. It can just be a simple gRPC API call over to the daemon to say, please go and load this on my behalf, and then everything should just work. When we looked at this. Oh, sorry.
I'm suddenly struck by the irony of how many people were kind of criticizing Docker for having a daemon for loading containers.
Right? Yeah, I know. Well, this is the funny thing, is that when I started talking about this with some people internally at Red Hat, like this thing that we just built, and how we were using it for XDP, and how we kind of had designs around helping solve some of the security problems and distribution. Like, that's a big problem, but hey, like OCI registries work really well for just arbitrary distribution of binary objects. So like maybe we can reuse some of that. And Steve Watt, who heads up the CTO office at Red Hat, said to me, Dave, like, is this like Docker, but for BPF? And I was like, I think you might be right. Like,
yeah.
I think ultimately that's kind of what we're going to end up building, is something a bit like that, that kind of gets you that from just some bytecode somewhere that somebody's written to a point where I can pull that down and run that on my machine and get like that instant fix of, oh, look, it's a web server, or oh, look, it's a load balancer, or whatever it is. I think that's, powerful.
Yeah, that's really cool. I think I'm also going to shout out to Bumblebee project, because I think they also use OCI registries for storing BPF programs. So which I think is absolutely in line with the intent of OCI registries. They're absolutely they're designed to be general purpose. The fact that they started off being used for container images, I think, is just the beginning of that story. So I think using to distribute other artifacts totally makes sense.
Yeah, and that was kind of where we wanted to like adapt this in future, is that we saw like Bumblebee does this really cool stuff, but it's not necessarily decomposable. There's a lot of, you need to opt in to doing it our way, build inside the container, you use our tool chain, use us to run it, but still the OCI bit we can agree on. So maybe there's some way that we can coexist there. Obviously BPF trace, awesome. But what if I want to run if I can compile ahead of time my BPF trace program, like, is there a very easy way for me to be able to then go and load that, have that stream out some JSON data to me, and then allow me to like not care about the BPF, not care about building a user space thing, but just load the BPF and then go take that data into somewhere and do something useful with it.
So what happens?
There's lots of promise.
Sorry, what happens if someone's already, well, either already or subsequently uses a different tool to load an XDP program?
Yeah, that's the problem. It's either everybody opts into doing it this way, or they're not able to attach the interface. So some of the little hacks
that I guess it's the daemon has already attached to it.
We've taken that exclusively.
Right.
So some of the little hacks that we've been workshopping in the background to make this work is using LD preload. So basically assuming that you're dynamically linking to libbpf or to whatever, we will just literally rewrite the functions that would load the XDP stuff to do that via Bpfd, and kind of pretend like it's working in some form of compatibility mode. But obviously it's not sustainable. I think that's really where we did all of this work, And I went to Linux Plumbers Conf, and then I saw Daniel Borkman's talk, and he's like, yeah, we've had all these problems with like multi-program stuff in TC. We want to go and solve this in the kernel. So now we're going to be able to have like multi-program for TC working nicely with sane ownership semantics. And then Toki stands up and is like, yeah, we'd like to do this for XDP. And then suddenly everybody's agreeing on the mechanism. And I'm like, oh, great. If we can solve this in the kernel, then from a user space standpoint, that makes it easier, because then all I need to care about is who's got what priority. And as long as there is some hook for them Bpfd to kind of hook in and say, look, no, I know best. Just because these things say that they want the priority of like 10 and this one says 11, me, the sysadmin, knows that, no, actually, like I need to do it this way because I'm running in the, whatever configuration. So as long as we can seed that control back into user space for certain things, then that I think is the natural evolution of Bpfd, to get out of the load path, because then we don't have to force every library to do it our way. We can just massage whatever's coming into the kernel in the way that we kind of expect it to look from an admin standpoint.
I'm really glad you mentioned Linux Plumbers. I had Daniel on the show a couple of weeks ago talking about exactly that, the kind of multiple TC programs presentation. So yeah, if folks are watching and want to check that out, then please do. Got a couple of people to say hello to. So hi to Rafa and hi to Sadiq. And also Russell has a great solution for us. We're just going to not call things CTL anymore, and then we won't have to have that debate. That's you should be a politician, Russell, I think. All right. Good question here from Vinay about leaf. I always think this is pronounced leaf. Please correct me if I'm wrong. Yeah. So what are the comparisons there?
So yeah, I started this about the same time that Leaf appeared, and there are a couple of differences. The first one is that our dispatcher program for XDP, and that is open source. It's here, it's in the repo, there is no magic involved. Whereas at the time in Leaf, none of the code that actually did that existed. You just had to trust that it came from somewhere in Walmart, and it would be fine. But ours was open. The other element is in the Leaf side, it was all related to tail calls. So when you use a BPF tail call, your stack gets halved immediately. So you get 256 bytes a stack, which sucks because 512 bytes is barely enough. And therefore, at least in this where we were just doing like function replacement, the stack should unwind between each function call, and therefore each stub should get its full amount of stack space. So we get past the stack space limitations. It's faster because it's just executing instructions and doesn't have to jump into another program. So yeah, this dispatch mechanism is superior to what happens in Leaf, is used in libxdp and is relatively standard. So yeah. And also, yeah, we use OCI for distribution, which is something which I don't think Leaf does. They have their own distribution mechanisms. Okay.
Do you have the option to load from, let's say, a local object file?
Yeah, you can load from a local object file as well. So we do that for testing, but ultimately what happened was it would be, yeah, if you just want some test programs, then just go pull this repo and then go get libBPF and then libelf and then the whole ctool chain and then LVM and then everything else. And then, go build these things.
Oh, yeah.
We're like, oh, all right, can we just, put it in containers, because then we can just share the same images for testing.
Yeah,
so
totally
that really motivated that.
I guess I was thinking about that kind of dynamic, where we have eBPF programs that maybe just get like a dynamic change, perhaps to reflect an address or something, which you might, just replace some bytes in user space, and then here's my object file.
Yeah, so one of the other fun things about Linux Plumbers was there was a really good talk on HID BPF for keyboards, mice, all of that subsystem basically migrating into being BPF for like drivers for random keyboards and stuff. And something has to load those things at some point. So our thought with Bpfd at the time was like, maybe if we had the ability to magically load some stuff from the file system early on in the boot process. So we are supposed to be run as a daemon by systemd. So you could just populate a whole directory of stuff to say, yeah, go load these bits of bytecodes at boot, and then we could be potentially there for loading drivers and other things. So again, it's like, why go write a service? Why go write your own daemon and have to figure out how to be well behaved inside systemd, where you could just reuse this one and not have to write so much user space code, where you can actually focus on where the value is at, which is more on the the BPF code and the bit that interacts with your maps. Like that's really the only bits you should really need to care about. And if you can get away from caring about loaders, I think then that's good, especially from a security standpoint, because then you don't get all of this loader proliferation all across your infrastructure.
That actually is a really great point. Yeah. Do you have any thoughts on how this might relate to things like signing? I know there's a lot of discussion of signed BPF programs, and some of the complexities around that relate to those programs being dynamically changed. So I don't know if that has a relationship here.
I'm so glad you asked. Yes. So Red Hat, one of the contributors to SigStore, which is a CNCF project, I believe, or Linux Foundation, one of the two.
Yeah, I think it's OpenSSF, but it's all,
it's all open. It's all open sourcey stuff. It's all good. But effectively, the parallel I see is it's like Let's Encrypt, but for containers. So we can have like that container signing capability. I can go sign the container. I can go create rules against with that. So because we're packaging inside containers, all of that container signing stuff, we can reuse that. So like I did a demo at Red Hat Next where I did this. So I set up my build environment. I went and packaged my stuff inside to a container. I can sign it. I can use like OAuth to sign it and say, it was signed by Dave at redhat.com because it knows me because I signed him through Google. But then I could also write a rule if I were added the code to Bpfd at least to say, only allow stuff on this system where the container that it's come from has been signed from somebody with an @redhat.com email address, which, is great because it gives us that provenance from the supply chain side that, the thing that we're trying to load into the system has actually come to us from a trusted source. Whereas I think, the BPF signing element, I'm not sure how they're going to deal with that provenance in the supply chain side. It's I'm not sure how that's really going to work. I'm watching that space with interest, but at least for now, I think that reusing some of that infrastructure that already exists for containers is handy.
Yeah. Great question here from Daniel. Can we use Bpfd for other program types, not just XDP?
Yeah, that's a good question. We are almost done through prototyping using this for TCBPF as well. And this is something which is close to our hearts, and I think to iSurveillance as well, based on Daniel's talk about the problems with TCBPF as it stands. Our solution was, well, hey, we can use the same dispatcher type infrastructure and sit in the middle, and at least we can solve that problem now before it makes its way upstream into kernel like 6.3, 6.4, 6.2, like wherever it's going to be, because that's going to take a while to proliferate everywhere. For things like K-probes, that's a bit more difficult because we don't, as user space, we're not able to control that ordering inside the kernel. It's like first come, first serve, and the kernel decides which gets dispatched first. That's not something that we can alter. But I am seriously considering, just from a lifecycle standpoint, adding support for K-probes and trace points and other things, because one of the things that nobody tells you when you get into BPF is about like lifecycle for BPF programs and how that can be very different based on the semantics of the BPF link type that you're using. So if you're using a recent kernel and you're using BPF link for trace points, then everything's great. But if it falls back to being a perf event, well, that's a bit different. The same with XDP. You use netlink, the thing's going to stay on the interface forever, like until you remove it. But if you use BPF link, then it doesn't. It's you get back the FD, and when the FD gets closed, the thing disappears. So if you forget to pin your program, then it doesn't stay there. And all of these little idiosyncrasies about the way that the BPF API works is stuff that we've tried to, in IR at least, isolate our users from, so that that experience is at least consistent across the board. But it does get confusing. So being able to say, well, actually, I'm just going to delegate to Bpfd to manage this thing, in the same way that we have like restart policies for containers, we can have the similar thing for BPF and say, leave this running until reboot. Leave this running until I tell you to close it. Run it for 5 minutes and then close it down. Being able to kind of defer that to some sort of external entity makes deployment a lot easier, because then all you care about is, does my map exist and can I interact with it? Which I think is a lot easier problem to solve for.
That is super interesting. I think it's definitely something that a lot of people, myself included, when you first come to it, struggle with, like, why can I use BPF tool to attach a certain type of program but not another type of program? And it all boils down to this, is there a file descriptor required to hold that link, let's call it, to hold that open? And that depends whether or not it's attached to something that has a file descriptor or not. So in fact, Michal, years later, the lifetime of BPF programs is still a complex mess. Well, I guess it's tools like this that are going to improve that situation.
And in the kernel as well, like, everything is moving more towards BPF link as being the way of managing attachments and lifetimes, which is great. But obviously, like, that's a perfect world in a later kernel and not like actual deployment now. And as being user space library authors, we see the horrible like mess that is user space now, of like, oh, well, this kernel doesn't support BTF, so then all of these types of programs don't work. And, oh, well, this one's only got 5.9 and they forgot to backport like all of these really important things from later kernels that make stuff work better. So the life of a BPF developer is going to be a lot easier when everyone's using, I don't know, 5.18 or something. Exactly. But proliferation into those LTS distros takes a while. And that's, tough.
Absolutely. Yeah. So just going to quickly show that we've had a couple of very positive reactions here from Vinay and from Naveen. So I think people are liking what you're saying here. And also Quentin makes the point there's a patch set around auto attaching more program types. So that could be, I guess, make everything more consistent. Yeah. Okay. Another question from Daniel. So if we're using OCI images to ship BPF programs, what does the manifest look like?
Yeah, we've got a spec for that in the repo. It's basically, right now there's like a silly compatibility mode, which is use a scratch container image and these labels, and then everything will work. But yeah, I think we want to move away from that and actually like do the work on getting a spec that works, but not just for us. Like, I want to involve people from Solo in that, so that we can actually like all agree that the OCI spec should look like this, and then we can hopefully build around that later.
Makes sense. Andrew giving us a smiley reaction. I think people are generally liking the idea of this.
Well, Andrew wrote the code, so like,
okay,
he's got vested interest. So like, thanks, Andrew.
So, I mean, you've already talked a little bit about some of the future for BPF, but what else is on your roadmap, and what are your future plans?
Yeah, I think for me, like, I've already done a lot of talking about future, but really it's evolving to be outside of that load path. So I don't want to enforce being the loader for all of the things, because I don't think that's a way to get adoption. Working with the new interfaces in the kernel and helping shape those as well from a user space dev standpoint. I can stand up now and say to people like Daniel, actually, I wrote a tool that's going to do policy for this. So like, could you please expose these hooks, because it would be really nice. So I think getting involved in those discussions and trying to shape that in a way where we can apply the policy that we want without being in the load path is important. Expanding out to more program types, but also like more on the security and policy side. Like, for me, one of the big things is, once we've loaded the program and you've got maps, then like, how can we more effectively manage maps? So how could Cilium say, I want exclusive read-write to my maps, but it's okay for other tracing tools to be able to have read-only access into them? And similarly for other programs, like how can we express these semantics in a way that, you know, we can all coexist on the same system and kind of share some visibility where it makes sense. I think that would be a really interesting extension on top of this work.
Yeah, that is really interesting. I'm wondering if there's anything in the BPF tool whose name shall not be pronounced. Are there any other sort of subcommands in that are worth talking about now? I mean, you showed us listing and loading and unloading. Are there any other subcommands right
Load,
now?
list, and unload. That's it.
Yeah,
There may be a run at some point, which I'd like to do, which would be, you know, run this program while I'm attached, and when I detach, then unload it, which is, you know, for that one shot like tracing type of program. But I think for now we're just trying to keep it simple, and you know, we're still discovering how this is going to be useful. So you know, if there are people out there that are like, oh man, this is going to solve a problem for me, like just reach out. Like we're building this for the community, and we want to, you know, make this useful for more than just what Red Hat wants. So yeah, come talk to me, and we'll work something out.
Which I think leads us on to a very good sort of way to kind of wrap up this conversation, unless there's more you want to add. How should people get in touch? I mean, there's a link to the GitHub repo. Are there other ways that you want people to engage?
GitHub is great. I'm on the Cilium community Slack, so you can reach out to me there directly if you like. Twitter occasionally. I'm terrible at checking Twitter these days, but you know, I will generally get back to you, or you can email me. That generally works, and I'm just datucker@redhat.com. So yeah, just feel free to reach out any way that works.
Fantastic. So if anyone has any last questions, there was one that I'm going to just scroll back and find. Oh, where is it? There was a really good question about. There we go. Well, not really so much a question, but a comment. Is it an Electron behind you there, Dave?
Sadly not, no. Little reface keyboard, a whole bunch of random synthesizer stuff, audio interfaces, and my favorite little box is a mod dwarf, which is a new toy. It's like an open source amplifier emulator and Stompbox emulator, which is rather cool.
Yeah, I will check that out. All right, so another comment saying that this is cool. Nice work. Thanks for sharing the details. I couldn't have put that better myself. So thanks so much for your time. Always a pleasure to have you on eCHO, Dave. So and folks out there, you now know how to find Bpfd, and I certainly will be checking it out. It looks very interesting. Oh, one last question here from Russell. Does any of that kit, and I assume he means the music kit, run at eBPF?
Not yet, but it's not to say never, right? There's always free time.
Yeah, I can imagine loading some, sound manipulation into an interface.
It's just a stream of bytes, right? You know, we all the hook points are there. All we need is
yeah. Maybe next time you're on the show, we'll be talking about eBPF and music. That would be a great topic.
Yeah, I'd gladly come back anytime.
Well, thanks to everyone around the world who's been watching. Always great to have you with us. I hope you've enjoyed this episode. I certainly have. And next week, Duffy, I believe, will be back. And then the following week, we're at KubeCon. So we'll figure out what we're going to do from an eCHO point of view. But as I say, do come and say hello. We always love to meet you in person. All right. Thanks, everyone. Bye-bye.